Buenos dias. My name is Cristobal Carambo. Thank you for this pleasure to be and speak to you all. I treasure you all very much. Highlight of every year and every summer is coming to Yale. So my unit was on the Dye-Sensitized Solar Cell, DSSC. I developed my unit in Dr. Brudvig's, or Gary as people called him, his class, in chemistry and energy sciences. I've been asked to speak about the content objectives, strategies, and standards that are in my unit, and I'll try to do that as briefly as I can because I don't want to get sick. So I was particularly excited to do this unit because it allowed me to, on a curricular level, combine chemistry, life sciences, biology, earth science, environmental science, and engineering into my chemistry curriculum. And normally you don't get to do that. And this particular unit allowed me to do that in a very seamless fashion, and I was very pleased to do that, very excited to do that. The other part of this one, on a pedagogical level, it allowed me to answer questions. So my unit is revolving around questions that we ask. A lot of our thinking about energy sciences has changed in the last couple of years because of research and increases in technology, so there are questions everywhere. And my unit allows me to answer one question that my kids always ask, it is, why do I have to learn this stuff? When will this stuff ever be useful? So this particular unit allows me to show them how science and technology and chemistry can answer a very pertinent problem that's still evolving as we speak, and we can use what we know in science to answer these problems and address societal issues. That's the first part. However, on a personal level, what I like most about it is that it allows me to do what I think most of us in our unit said, that our responsibility as educators is to try to inculcate in our kids a sense of their responsibility for the environment, right? How do we get these kids to understand, teenagers no less, that they are responsible for the environment now in their present life and in their future life as parents and as citizens of society? So the unit allows me to address these kind of questions, and that's what I really liked about starting it. The unit is about a 14-day unit. I just briefly began it about 2 weeks ago, and it covers a range of topics, and it begins with an evaluation analysis of the current debates and the current evidence on climate change and energy policies, especially the use of fossil fuels and greenhouse gases. And the way we do this is we do a couple of guided analyses of videos and papers, and we have one great video that Dr. Brudvig showed us about a series of rap artists that talk about how our responsibility is, remember, our responsibility to the planet, and sort of kicks off the discussion. The unit is framed with lots of writing and research, so it begins with that kind of conversation on a societal level. But on a personal level, kids always say, well, these problems are so daunting, what can I, one person, do? So what we do is we do an ecological footprint analysis. It's an online survey. The kids take this analysis and they realize that their lifestyles are very unsustainable. So after that first part, we do a classroom discussion of their unsustainable lifestyles. We discuss ways in which they can change and ameliorate their usage of energy, specifically the carbon footprint. And then they go back and they redo the footprint analysis and see how some of these projected actions can really lower their imprint, correct? They get extra credit if they involve their parents, and they get their families at home to say what they do, because parents always say, I ain't doing that high school stuff. But it's really important to understand that they, as responsible stewards, have to tell their parents, you know, hey, let's get this done. So continuing that, after we do that initial part, we do a science objectives, and the science objectives really focus on environmental science, earth science, chemistry, and biology. They focus on, the key thing is electron transport, and how electrons are used to transform light energy into electrical energy or into chemical energy. And the really good part of it is that I can really focus on biology, especially photosynthesis, and the photosynthesis, right? And I'm not going to do a test right now, but you know, plants take light energy, make it into electrical energy, and store it in food energy, which we all consume on breakfast, so I can do all this stuff with my hands, right? So we do that, but then the analogous process in the solar cell is that solar cells use a similar process to capture light energy and turn it into electrical energy, and specifically semiconductors. And this is where it's really good for me, because when I do my periodic table and I do, you know, metals, non-metal, semiconductors, everybody goes, yeah, who cares about that? But I showed them the cell that I made in school this summer, and I said, this thing right here will change that light energy into electrical energy. And we actually hooked it up, and we used their cell phones to power it, and they said, OMG, this really works. So that was a very powerful moment for me in my class. The strategies in this part of the unit are basically on building the solar cell. It's about a 4 or 5 day unit. It's a very concise, inexpensive kit, and you actually make a solar cell, which I made this summer. We use it in class, and it actually works. And then we're going to do variations on that cell to see how we can increase its efficiency and make it work better. And that's the engineering design part of it. That's really good about it, okay? So I'm going to go quickly. The standards fall into two broad categories. Since there's so much writing and research and analysis, I use the Common Core, the literacy standards. And my favorite one, which I wrote, it says, synthesize information from a variety of sources into a coherent understanding of a phenomenon. And my favorite part is resolving conflicts when possible. And none of this debate about climate change and energy usage is flat. You know, it's all up and down, up and down, up and down. And what I want my kids to understand is that whenever you have a debate like this, you have to look at all sides, think of where you fall, and then come out and your position. So I'm not going to proselytize them into saying climate change this or that. I want them to come up with their own opinions. The science standards are really from the whole realm of earth science, space science, environmental science, and they look at really how to integrate the ideas of electron transport in biology and photosynthesis into this particular unit on the dye-sensitized solar cell. So far, so good? All right, we're good. And what I was really interested is in the engineering part, because engineers plan things, they make things, they change the way they work. So our cell, we do blackberries and fruit to dye the cell, but then we also take chlorophyll. So we make a cell that's very similar to the plant cell, and we see which ones are more efficient, and we talk about how you can make them more efficient and how you can make them work. Because the problem with all this newer energy sources is that many of them are inefficient, they're very expensive, so what do? A question that we have. And one question that we had great in Dr. Budwig's class, am I okay on time? Yeah, get close. Okay, was what now? You know, what do we do now? And there was a great article from The Atlantic that said, what now? What do we now, since we're energy independent, how do we approach climate change? How do we figure out the responsibility to respect the environment? In closing, my student responses were great. I just broached the periodic table as I told you. We talked about semiconductors, and I showed them the cell, and that was really spiffy keynote. But then the best part was I said, we're going to build these ourselves. And so at the end of the unit, which will start probably mid-November into December, we're going to take a lab, and it's pretty easy to do. It takes a minute to figure out, but it's a very easy process, and each child will have their own solar cell they can take home, and they can show their parents what a real solar cell looks like that they made in class. Thank you very much.